And we're back. Welcome back, ladies and gentlemen, to another episode of The Good Thing. You might notice I'm not in my usual studio today, and this is actually a recording. Reason why is I'm actually out this Friday heading to a funeral. So I will be out this Friday, but we wanted to stay consistent and make sure that you guys get your daily or your weekly viewage of The Good Thing. Jens, as always, good to see you. How you doing today?
I'm good.
Typical German response. Not bad. I'm good. It's the
It's
same every
okay.
week. That's
Yeah.
awesome. Well, thanks for joining us. Today, we're going to be talking about what we call Conway's Law and just kind of going, I wouldn't say like off script. We don't have a strict agenda today, but I kind of wanted to talk about organizations, what we're seeing with the rise of AI, just kind of how companies are adopting AI, where we're going with AI, and just kind of like APIs and how it fits into that space. But the first topic I wanted to talk about is Conway's Law. This is a law that I learned about when I started at Wondergraph, but it's one of those things, and I'll give you, like, a story is, I'll forget, like, when I was in college, I didn't understand recursion. I couldn't understand it, I couldn't, like, figure it out, and for the longest time, like, the exam was coming up, and I was scared. I was like, "I don't understand recursion. I don't know understand why anybody would use it." And, this was a solution to a problem, and what I realized quickly was I couldn't figure it out. There's no way. I spent hours in the lab trying to figure it out. It didn't make sense to me. But then when the test came, they gave me a problem. And I was like, okay, well, to get to the solution of this problem, what's if I go 4 steps this way and then to the right and then just keep kind of doing that? And then it just kind of clicked right there is what I was doing was recursion. And so because I had an actual problem and I had the solution in my brain or in my toolbox, it clicked in my head. And what I'm trying to get at is I didn't get Conway's Law in the beginning. I didn't understand it. But now, when we work with these enterprises and we talk to them and we learn about their tech stacks and their architectures, and then we actually talk to their teams, I'm like, holy crap, like this is Conway's Law at play. And so I want to talk about today of what we have been seeing with Conway's Law. And this is a very simple paraphrase version of Conway's Law. But basically, the structure of your software will mirror the structure of the organization that built it, which I think is super fantastic. And like it's kind of cool how he figured this out, but it totally makes sense. I'll pause there, Jens, though. Like, what have you seen lately on Conway's Law? And just, I mean, we talk about it all the time, but why is it important?
Maybe before we talk about that, I'm curious what observations have you made talking to to customers?
Well, it's cool. So, like, for example, us, we're a single monolith, one mono repo, and that's how we work. Everybody works to the same contributing. And then with our customers, what we'll see is that there'll either be one large team working together with a monolith. And what's quickly you realize there is they want to take that monolith and they want to break it apart. And the reasoning isn't actually the software, it's what's happening inside the organization. We're moving too slow, we're stepping on each other's toes, it's just getting too big. We're a company. And what you realize quickly with these companies that go from monolith to federated architecture is that they started off small, which is great, but they grew very fast. For example, we have a construction company that grew from zero to IPO in about 6 years. And what they've quickly realized is we've built this huge legacy. We're one big team, but we're so slow. We cannot be slow. And so what we're looking at is a federated architecture to break it apart. And that's where federation comes in handy. And then what you also see is these small distributed teams that kind of started out from the beginning. It might have been a little bit of a hurdle at first. A lot of times we tell people you're too small for federation, but for them it ended up working, and they kind of have this modular type where different teams own different services and they all work together. But that's kind of what we're seeing within the companies is that if you remove the software and you don't actually talk about the software, just look into the teams and ask them like, okay, how are you working together with team A, B, and C? Or are you guys just one team? How do you push code? How do you collaborate with those teams? And I think that this Conway's Law, it's more about the teams than even about the software. You can always figure out what software they're using with, or like what architecture that they have by just talking to them and how they interact with each other. So that's kind of what I've been seeing. What about you?
I think when I was first introduced to Conway's Law, there was an um like an example. Let's say you have two teams and they want to build a compiler. What do you think? How many steps will the compiler have?
How many steps? If it's 2 teams, how many?
Get
10 steps?
you said the number before.
2.
Yes. So and that's the interesting part. So at the very beginning, I didn't really understand what is the meaning. I didn't have so much experience yet, and like, okay, yeah, it's interesting. Two teams build a compiler. Compiler has 2 steps, but what does it mean? And in reality, what I would say, one pattern I learned in software development is code that changes together. It should be very close, and code that doesn't change together, it should be like further away. So for example, code that changes together all the time, it could be in a package, it could also be in a function. So the closer the code is together, the easier it is to change it together. For example, if you look at our architecture, you can kind of see that we have somehow 2 teams, not
Yeah.
one, but 2. We have graphical go tools, we have the engine, and we have the router. And you can see there's a clear line between what does the engine do and what does the router do. And so some modules you will see, or some functionality we do it in the router, some functionality we do it in the federation layer. And so yeah, you kind of can see how the way we shaped our organization, the way we kind of, even if it wasn't like a real split, but somehow it was kind of a split in terms of communication, because our engine team, it was always a little bit like on the side. And yeah, I think you can see that also in the architecture. And then if we look at our customers, I think one very interesting observation is, um, you can see the structure of the architecture they built. You can see it in communication patterns. You can see it in which people join on a meeting, how they work together, how they communicate. And I think it's a very interesting problem. And also one observation we made is that different API styles have an influence on how you can deal with Conway's law. But before we dive into that, I pause, and maybe you have some other thoughts or questions.
Well, it's interesting. Like, you say it's a problem, and I know it's a problem. We can see it's a problem with the companies that we work with, but, like, what what would be a good organization structure where you wouldn't run into this problem? Because it just simply mirrors how you guys communicate. And, like, obviously, the answer is with APIs and just having a good structure and being able to communicate cross teams with APIs, but have you seen from one of our customers maybe a good structure that they have, an organization structure that tends to work for them?
I wouldn't say per se Conway's law is a problem. It is more like, yeah, it's more like the reality. And so
Yeah,
the question is, does your workflow fit this reality? For example, if you want to make let's say you build an app where people can book like a limousine service or something, and let's
nice.
say to add one single button to this front end application, you have to make changes in 7 different places in 7 different systems, and they are all like super complex, and you have to talk to different people and whatnot. At this point, the question is, have we built a system that prevents our engineers from making changes? Because obviously you want to change a button, but if you have to change multiple systems that are all over, does this code structure, does it support us in making changes to this code base? And yeah, I think this is very tough, and you need a lot of knowledge and seniority to make changes in such a code base. Versus And this is something I think a lot of people they got tricked a little bit into following microservice patterns or trying to adopt modern patterns. For example, I would say one of the biggest anti-patterns you can establish in service architecture is you have one single team, and you're thinking, and let's say you're 5 developers, and you're thinking, microservices seems modern. Let's build a microservice architecture and split out certain functionality into a separate service because we want to make it scalable or something. And
Yeah.
I mean, there's many stories of companies that have used something like Ruby on Rails, for example, GitHub, and they scaled very, very, very well. So there's a lot of these stories where people will be like, oh yeah, we have a monolith, it scaled to a certain degree. Like now we have some problems, but it scaled really well for us. There's very few stories of companies that say, oh, our company completely messed up, like we went bankrupt because of our monolith. I have never heard such a story, but there will be many stories where people say, well, we messed it up with complexity and our microservices architecture is too hard. um, because the point is, if you are a single team, 5 devs, why do you need to split anything into another service? Why can't you just focus on solving the problem? And solving the problem typically means just create a boring monolith, solve the problem, move forward. For example, in our architecture, we have Cosmo. We have one backend. It's called control plane, and it's one backend, and it's okay. We have like an RPC contract. This RPC contract, we use Buff Connect to implement this, and it can be called from our front end, and it can be called from the CLI, and that's okay. We can generate clients in Go and TypeScript, and we call it a day, and that's it.
Question there though. Have you ever worked or seen a company that started with the microservice architecture and was successful, or maybe read about a blog where they from the beginning they started with the microservice architecture and it was successful?
So I did that in the past, and the project was killed.
So I don't know if you would say that was a success, but I mean, it's interesting. Like I hear it all the time. We'll talk with people and they're like, "Oh, we're preparing for scale." And it's like, why don't you hit scale first and then deal with the problems that come from it?
um, I mean, I can speak for myself. If you are, I don't know if every engineer has this journey, but for me, I made it. I mean, you know me quite well over the years, and I made a huge journey from being obsessed about tech to, so that was my past, and now being obsessed about solving problems and figuring out how much deeper can we go in the problem space, and what else can we do for customers. And I kind of transitioned from thinking so much about tech and more thinking about what can we enable, what can we achieve together with our customers. Nowadays I find it more interesting to building like a great product and to solving the hard problems for our customers, not so much how we do it, like which tech. But yeah, I guess like a big problem some developers have, like me in the past, is we read these blog posts from Netflix and whatnot, and then we're like, oh, I also want to be like an engineer from Netflix. I also want to use Kubernetes. I also want to use Go and microservices, and I want to use GraphQL and Federation and Relay. And yeah, I don't know. Maybe it's a little bit of resume driven development. Maybe it's a little bit about hype. Maybe it's anxiety, like you need to stay up to date with the stack or something. I think there can be many reasons, but I would say if you want to make a successful career in tech, and you're an engineer, I think the engineers who make the most money, those are people who understand the root of the problem. They understand the business behind the code, not just the code, not just the tech. They understand the customer, and I think they are getting closer and closer to the customer. There's a distinction for me between someone who writes code and someone who solves customer problems. It can be the same person solving customer problems. It can mean to write code, but you shouldn't writing code or creating architecture or building services. It shouldn't be your one hammer and then you want to hammer it everywhere. You should be more focused on, okay, what does the customer really need? How can we solve it? And tech is, do you know in it's funny how I go from one to the next, but do you know in when you go to car design, there's a saying like form follows function. I know it's not what people like who do art and stuff, but uh, sometimes it's just easier to think about the problem, and then you derive the solution, and going like, oh, we're building a new thing, let's create microservices. What problem are we solving? Are you really focusing on the problem, or are you prematurely scaling because you're like, I yeah.
You hit a couple good points there. And last week, somebody posted on Hacker News. They posted the screenshot of when they announced Cursor. And the top comment was a developer saying, I don't understand why this is XYZ. I just did this. This is just a fork of VS Code. This is VCBS. Oh no, it wasn't Cursor, it was Windsurf. And then somebody posted it on Twitter and was like, Windsurf acquired for $3 billion. And I posted a comment which was like, I've noticed that developers get obsessed with the technology and not actually solving about the problem, which is true because they focus more on the technical implications. Like, sure, Windsurf is more or less not a super impressive piece of technology, but what it did is it solved the problem and it solved it pretty well and it solved it pretty quick. And I think you're spot on. And if you remember the Dropbox example, do you remember when he announced Dropbox and developers started ripping into it? They were like, oh, this isn't that. Like, that's not super impressive because they were just talking about the tech, but they were not solving about the problem is that now you can transfer files into the cloud with the click of a button. And I think what you said is the nail on the head. It's resume driven development. They want to say that I've built this with Kubernetes, I've added microservices and things like that. I don't know. For me, it's cool. I've always seen coding as just a tool. It's a means to an end. Coding isn't anything else but a tool that helps you solve a problem. Same thing with programming and architecture and software. All it is solving your problem, but you should be obsessed with the problem, not how you get there or the tools that you use. Like carpenters, I mean, you were a carpenter, which is a great example. You liked building things, but you weren't obsessed with your hammer. You didn't be like, oh, hammer for everything, hammer for everything. And it's like, no, we need to build a drywall. No, hammer. I'm going to use my hammer. And that's the way I see developers that are obsessed with, like microservice architecture. It's like, oh, I have this new hammer. It's golden and it has a different claw or a sledgehammer, and it's going to solve our problem. And it's like, mm, I wouldn't agree to that. What do you think?
Yeah, like you can be super obsessed about how you build drywalls, and you can have your like your craziest setup and tooling and whatnot to do drywalls, and then the customer, they will take the drywall, they will paint it, whatever. They will not care about your drywall. They just want a drywall. And yeah, this is another interesting point because another observation I made about myself, but also other developers. And by the way, I'm not ranting about developers. I also have a lot of empathy for resume driven development because as a developer, you always have this. I don't know if you had this. You were a developer also for a time, but I always felt a little bit like an imposter. I always felt like, I don't know. There's people, they know so much more. Like I need to learn faster. I need to understand more. So I think imposter syndrome, it's a real thing as a developer, and yeah, you can really have anxiety that you're not able to catch up or something. So I think, yeah, there's something to just trying out new things and stuff. But I would also say it's a thing of experience. And one observation is that over the last couple of years, I feel like on one hand, software development became increasingly more complex. Like the tools we have today, they're just so much more complex than what you had in the past. You know, when I learned programming, you would have a PHP file and Apache server or Nginx, and you would upload your PHP file with FTP, and then you have a website. And that was okay. That was it. And maybe you had a MySQL database. And today, look at our stack. Front end, we have Next.js. Then we have Keycloak for federated authentication. In the backend, we have Node.js. For the database, we have Postgres. For caching, we have Redis. For analytics, we have ClickHouse. Then we have OpenTelemetry for telemetry and tracing and metrics. And like, holy shit, it's so complex. This is one part. So you have a lot to learn to understand this modern stack. And then the second part is last couple of years, like last 10 years, there was like a huge influx of new developers. There's huge demand for developers. And what this results in is that if you have demand for developers and on such a steep trajectory, what it means is that the majority of developers, they actually have like below 2-3 years of experience. So I think we are now at a time where the majority of developers, they are not seniors. And
Mm-mm.
so combining these two, a lot of not seniors, a lot of junior mid-level people with not so much experience, then you have this ever increasing complexity of the stack of the web. And now you combine it with AI and whatnot and vibe coding, and now everybody has anxiety and what is next. And you now have this new generation of junior devs. You give them cursor, they vibe code something together. They don't even see that it's broken or that there are security vulnerabilities. They have never done it by hand, and this is something, I think it's something good about when you do an apprenticeship as a carpenter. We have machines to do carpentry, and you can automate many of the steps, and there's like super cool tooling. But if you do an apprenticeship, the first thing you do is you do these kind of things by hand, and it takes a lot of time, and when you mess it up, you have to do it again, and you really learn the details, and that might be something in software development that we're lacking a little bit.
I want to add to that. Like, if you remember pre-COVID, like engineering was up and coming, like not up and coming, but like we were hiring like crazy. And then COVID hit, and the number of engineers being hired was like crazy. Companies like Zoom, Cameo, all these companies exploded hiring engineers. And one unique thing came out of it, which was boot camps. These boot camps were exploding. Everybody was becoming a developer because as soon as you graduate, you'd get a job for 200K somewhere in the Bay Area, and it was insane. And there was basically this gold rush of developers. And the point that I'm getting at is if you look now, boot camps are dying. And the reason that they were dying is because they were just like a mill. They were taking in developers, they'd give them Flask and a little bit of a database and some experience, and then they would send them out into the world. And it's what you said, they were very junior developers. And the reason that they're dying now is because if you give a person with a little bit of technical knowledge cursor, you're getting the same output that you get from one of these boot camps. You're getting a very junior engineer that has a lot to learn. And what the boot camps did really wrong is they didn't actually give real life experience. oh, build this to-do app with this database. Okay, boom, there you go. And you can do the exact same thing with Cursor. And so it's kind of interesting. And we were talking about this today as well, is with AI, like people are on one side of the fence is that AI is going to make developers 10x faster and better, or the other side of the fence is that we're going to replace developers with AI. And I think that's super interesting. And I don't understand which side of the fence I'm on. Obviously, I'm on the side of the fence that it's going to make developers stronger and faster and better because you're always going to need good people, good technologists. It's like what you said is imposter syndrome is a very real thing with developers because engineering is one of the only careers where you have to constantly relearn everything. Like, for example, doctors, they finish medical school, and then they have continuing education every 2 years, where they go and they just get up to update practices. And the thing about the medical field is a lot of the stuff doesn't change for 10, 15, 20 years, or it never changes. Like, you're still doing stitches the same way that they were doing them in the 70s. And that's totally fine. But with technology, if you were a developer in 1997 and now, your world has completely changed. Like, and what's cool about technology, somebody wrote this, I forgot what book, but every 17 years, technology, like everything that you know about technology is completely wiped away. Like back then, it's what you said, you had the FTP, you'd write a file, and boom, that's a website. Back in the 90s, if you knew how to run servers and machines, you were an anomaly. You could build things. Now you don't even need to understand how the cloud works. You could just tell ChatGPT, hey, help me connect this with AWS, and boom, you have something running on the cloud. And I think you're absolutely right. But with this transition, what do you think about that fence? With AI being introduced and Cursor and all these tools, what do you think is going to happen to developers? Are they going to get stronger? Are they going to get worse? Or are they going to become obsolete?
Yeah, that's a great question. Um, I mean, I'm biased. I'm a developer myself, but I would say maybe I'm naive, but so you have two options. You replace developers with AI, so that means you can achieve the same goal, but with less resources. So you're more efficient, but the outcome is still the same. Or you have the same resources and you accelerate you increase your outcome. So I would say if you can increase your outcome with AI, it means you can release faster, you can release better, you can release more. So that means you will learn faster, you will get more experience into the market faster. So ultimately, I think that will compound, and people who replace developers with AI, I think they will slow down because they kind of have like a flat going function or a function that goes slightly down, even though they are more efficient, but they are on a dying slope. Versus, I think the companies who will um, who will keep their developers, give them AI, or keep the right developers who understand AI, I think they will be more like on an exponential function. So, there was this old saying like software is eating the world. And I'm wondering,
Mark
companies with,
Andreessen, right?
yes,
Yeah.
companies with the right mindset, with the right engineers, with AI, I think they can accelerate even more. And by the way, I kind of have developed an opinion that when we now interview people, I ask them how they think about AI. And if they are against using AI on the job, I see it as a red flag, because I think like nobody should be wipe coding or just like, I don't know, like use AI to do random stuff. But I can give you an example how I used AI today. So I wanted to write an RFC for a new feature. And I knew, based on my domain knowledge, there are like 7 links that point to our GitHub repository, to our docs, to some other documents, to our to some code examples. And so I compiled a list of links to research. I added a bunch of requirements for my RFC, and I didn't intend to use AI to write the RFC. I just wanted the AI to do the research and to give me ideas. So
Yeah.
I go to ChatGPT and I go to the deep research mode. I give it the links, some prompts. So I actually invested like 10 minutes into really articulating what I'm looking for. And then I make a coffee or something, and 5-10 minutes later I get a well researched paper. I can review it, and I'm not even considering using that for my RFC. It's more like, okay, now I have this in my brain, this dump. I will sleep over it, and now I have some fresh ideas, and it's as if I had a conversation with a senior developer who read all these 7 documents, and they gave me some thoughts, and now I'm one step further. And if you're not using these kind of tools, if you're not trying out how Cursor could help you, and I'm not saying like, LLMs, they generate tokens, okay? Like it's not intelligence, it's not smart in any way, but I think we as developers, we have to reimagine our job, because we're not code writers, we are problem solvers. And for me, describing a prompt and working with ChatGPT deep research to figure out how to solve a problem, for me that is engineering. So my
Hmm.
job hasn't really changed. It's just I'm now doing it at another level. And I'm honest with you, in the beginning it's kind of fun to write code and to see how it compiles and runs, but after several years I'm still very interested in solving problems, but I'm not going crazy about typing words to make it like it's not so important for me to type every single character, if you know what I mean.
I think you're spot on. I really like that example. And one of the things I'm noticing is like, do you remember like when Amazon was being built or just the internet and people were like, oh, the internet's just a fad and it's just something that's going to go away. And what I'm sometimes hearing, which is crazy from people, is like, oh, AI is this just bubble. It's going to burst. It's not really that useful or whatever. And the thing is Shopify and now Duolingo, and I'm telling you, all these other public company CEOs are going to start doing the exact same thing, which is the API or like the API mandate, but the AI mandate. You have to incorporate or at least be using AI into your tooling because it's what you said. It's just a tool, but it's an extremely powerful tool. And I do think it's a red flag as a technologist not to use AI because as a technologist and a problem solver, your goal is to use the best and most available tools at your disposal to solve that problem. And it's what you said, like you could have spent 10 hours, 15 hours doing deep research, reading all those things and everything, but instead you prompted it, you spent 10 minutes describing exactly what you want, you pressed enter, and you went while it was compiling and building and getting all that information, you went and you made yourself a coffee. And you might not be at step 10 where you're finished, but you're at step 5 and you did that in 10 minutes. And I think AI is such a powerful tool for that, that when we hear in the interviews like, "Oh, I used AI," it actually makes me happy because it's like, okay, you're using tools at your disposal. And one example I'll draw back to is when I was doing my computer science degree, every exam was open book and open computer for this one teacher. And this teacher said, this is what he said. He's like, I don't understand professors that don't let you use your computer or your book because in the real world, when you're an engineer, you're going to have Google open. You're going to have everything open so that way you can solve all these problems and you should use every tool at your disposal. So it doesn't make sense for me to create this environment in this classroom where that's not the truth. But it's going to be hard problems and you're going to have to be able to use the internet. But I agree with you 100%. But to go back to the question, like, I'm also with you. I think AI is gonna empower developers. I not yet. I don't see a world where software is just being built by AI, but could it happen? Do you think sometime in the future that, just things are being built with AI and that there's no like the way I envision is have you ever seen Iron Man What was the name of that AI villain that he created? There was a whole Marvel Avengers on it. I think it was the second one.
So I know Jarvis, but that's not what you're looking for, right?
No, Jarvis is the good one, which
Yeah.
could be amazing, but there was the one that was so smart and so sentinel that it ended up being bad, and it hated Tony Stark, and I forgot the
Mm.
name of it. I'll post it later in the comments. But with AI, do you ever see a future where like it's kind of like its own thing? It solves problems and it works and it just does its own thing without humans? Like we've built it and at this point sustainable?
So there's probably people smarter than me, and they have more knowledge about what's going on in the AI market. But from my perspective, where we currently are at is we have agents like LLMs. We prompt them something. We can give them tools, for example, through MCP, and then they can do like more complex tasks. And yeah, the results are okay. Like some tasks they are really good at. And now there's like a new protocol, agent to agent. So instead of one agent doing like a super complex task where it would get stuck, we divide the task into smaller pieces, and then agents can essentially call tools, and these tools are other agents. So now we have agents collaborating with agents on like more complex problems. I don't think this is intelligence. It's still LLMs. It's still each agent does a task and it can predict something, like the next token, and it can. I mean, you can train these models further and further. It will not be intelligence, but it will be extremely capable. We can automate it, and it will be able to do things that today humans do. It will look very intelligent, although it's not. And um, so coming to your question, will that AI, will it replace how we do software or something? I'm not sure in the current form. I think what is currently missing is like motivation. Like um, what you don't see in LLMs is they are not really motivated in doing anything. For
Yeah.
example, when I did some experiments with Cursor, like one workflow that is quite useful when you work with LLMs is you write a test and you ask Cursor to make the test go pass. And the stupid thing is that Cursor doesn't really care of if your code is right, and it it doesn't know exactly what does it mean that code is right, or it also doesn't care about your business or that this is scalable or whatever. It's just making, yeah, you ask to make the test pass. So what can happen quite likely is that the implementation looks at the test and it somehow implements the logic in a way that, yeah, it makes the test pass, but this is not good architecture or something. And now you have you have a bigger problem in large organizations, I would say, because imagine you have a big org, you have 1,000 developers, and they all work on several projects, and they all want to achieve something. What is the biggest problem, like from a software engineering perspective? From your, what do you think is the hardest problem if you have an org with 1,000 devs? What is the number one challenge?
Communication?
Yes. So it's all about how these people communicate, how they make decisions together, how they how they shape ideas, how they shape projects, how they prioritize things, and ultimately how they make this whole organization scalable, in a sense. Not scalable from like building scalable software, but um, finding out a scalable approach of building software, so enabling more value. And um, what I really don't see is like I've never heard any AI company, whatever, talking about um, how will we have thousands of agents collaborate in a way that it's any meaningful, that it's helping the company to achieve goals. And when I have one single cursor instance and it's doing weird stuff with my tests, what happens if I have, I don't know, a
Thousands.
thousand ones, and then layers and layers of agents and whatnot? And who controls that they do the right thing? Will this be other agents? Okay, now you have an agent controlling an agent, but who controls the agent who controls agents? And I don't know. Ultimately, yeah, maybe some smart AI people will now laugh at me, and they will be like, oh, Jens is naive. But I currently live in this naive world where I think AI is a pretty cool tool to help us generate code much faster for a context that we have very, very well defined. But defining this context, I still think at this moment it is our task as developers to figuring out that.
Well said. And I think like it's one of our key theses, and you'll see it on a landing page. Everybody says it, but I really like the word that they say is that there is no AI with APIs, and I think that's super important because how are these, MCPs or these agents, how are they talking to each other? Like, how are they making sure that everything is working correctly, and how are they communicating across people? Like, for me, the best example that I've heard, we're writing a blog post on this, is when you go to a restaurant, you look at the menu, that's the front end. The back end is the kitchen that has the food, the data. And then when you want to get food, you talk to the waiter. You tell him what you want, and somehow the food appears there. That's that communication layer. And it comes from communicating with him. And that's essentially what APIs are. It's just that communication between the front and the back end. But with AI, there is no AI without APIs, is what Kong says, and I like it. But where do APIs fit into this equation of agents and MCP? Is there going to need to be APIs? Can't they just talk to each other as if we just talk to each other? Or is that talking still the API, if you know what I mean? And I think this is really interesting question for you because you have a thesis of where the world is going to be with APIs and AI. And I like it and I fundamentally agree with it. But where do APIs fit into this AI bubble and wave?
So let's say you have an app and it can send money to someone else. So you want to send money to Sophia. Okay, you enter the amount, $100. You intend to send $100 to Sophia, your wife.
Mhm.
And what would you do if it would send $1,000?
Well, it's to my wife, luckily, so it's still to my bank account. So I wouldn't be too upset. But let's say it was I sent it to the wrong Sophia. I sent it to like my
Okay,
cousin on
wrong. Yeah,
a friend. I sent it to a friend. I'd be a little bit upset. I'd be
a
like,
friend.
shit. Yeah, I
Okay,
just lost my
so
$1,000.
so you want that your app is very accurate.
Yes, of course.
Okay. Um, and if we build a contract between your app and the back end of the bank, and then we have interbanking contracts. We have things like open banking, which is open API for banking, and all these contracts, like your app talks to a server, the server talks to another service, the server talks to another server, some other server talks to a database, etc., etc. If we have strict contracts, like where we say, okay, here's our open API spec, here's the JSON schema, you have to send money in a specific format, and if you're done doing it, we give you a 400 bad request, and that's it. So play by the rules, otherwise it's going to be a foul. All right, so that is what we're doing today. Now you're saying, can't we just replace all of this with LLMs and stuff? And
I'm already
the
seeing it,
answer,
by the way. I'm already seeing where you're going. I like it.
no, but so your front end LLM, it sends text to the next server. And this text could contain, please send $100 to Sophia. And then the server goes like, okay, I'm sending $100 to Sophia. And maybe that's even right. And then you have like multiple other agents and they all collaborate and they all have text as the communication method. And the problem with this kind of style of communication is if you just use raw text, the way LLMs work is you tokenize the input. So you take the bytes or whatever, you cut them into smaller pieces, and then the LLM tries to make sense of what these pieces mean. We call them tokens. Okay, you have these tokens, blah blah blah. And now in each server you have like different models. They might have trained on different data, and maybe they slightly send different messages. And if we're super lucky, they all do like the right thing. But then there's also, for example, a thing in LLMs, we call it temperature. So temperature, it can allow an LLM to have some sense of creativity, some sense of randomness, so that it's not always writing like the same boring stuff. But if you ask an LLM to write like a story, then you can increase the temperature and it will be more creative and something. But this creativity, it can lead to hallucinations. So it might somehow get something into the context window and then it starts, I don't know, it starts rambling or whatever. So do we want to build a world that works like 60% of the time? Or
What's your quote though? Your quote, it works what?
it works 60% of the time, all the time. No, I mean you know it, but I think this world is not gonna work. We need to have safeguards. And let's say you have like an MCP tool and your kitchen gives you an MCP server and your waiter, it's an LLM. And so what kind of needs to happen is you speak to the LLM, you tell them, here's what I want to eat. Like I want to have pizza margarita and one beer. And then the LLM could come back to you and say, Stefan, do you really intend to eat pizza margarita and one beer? Is that what you wish? And you say, yes, that's exactly what I want. So now the LLM, it can now do an MCP call for you, and it will say, hey, on your behalf, I would like to make an MCP call to the kitchen to bring the order. Here's what I would send. And now in Cursor, if you look at this MCP tool, you will actually see it will construct a JSON message to call the MCP tool, because MCP uses JSON schema to define like what is the input. You can verify it. And now you see that we gave the LLM like a very strict contract how to talk to the MCP server. And so I think LLM is pretty cool if we put it on top of APIs. And if you look between the lines, like what is MCP, then okay, it's APIs again. And at the core of everything, we need APIs, we need strict contracts. Otherwise, banking wouldn't work, like nothing would work.
I think that's a fantastic example, and I'm gonna have Jacob clip that because I love the waiter example when I'm talking to non-technical people, but when people ask why do you need AI with APIs, it's simply because of banking. Like you say 100, it accidentally sends 100,000, and it's because it hallucinated, the temperature was a little bit up. And what APIs are providing to this world are the safeguards. And I think that's what the Kong founder means is there is no AI without APIs because APIs provide the safeguards around that. I like that. I really like that. And we are about to be at time. We are going to end the episode a little bit early because we do have a couple customer calls to get into. But Jens, one last question before we jump into that is, where do you see the future of AI, but like with APIs, and how does Cosmo tie into that? Because we're working on some exciting products, and I would love to just have a little bit of time of you talking about it because I think what we're building is really powerful because what AI allows is productivity. It doesn't really allow collaboration. What APIs provide is the safeguards, and what we're building is at the intersection of collaboration, productivity, and safeguards. But can you talk a little bit about where you see AI and Cosmo and APIs?
So what we're currently seeing is big companies adopting tools like Cursor and changing the way they create software. So it's now like senior architects or senior engineers who now focus on developing the right prompts and everything, and they are migrating legacy servers into the world of federation at lightning speed. So it's a very interesting observation. It was never cheaper to migrate legacy and modernize it and consolidate services. And one we just talked with one such company. We joined one of their guild meetings. So they have like a GraphQL guild that meets every Friday. There's not just one guild in the GraphQL
That's
space.
what I'm saying. It's a community. It's a community.
Yes. So they had this guild meeting, and one developer showed an example where they have a single query, and this query loads data from like seven subgraphs. And before they had this implementation, the front end would have made like 20 calls to various services to get the same data. Now it's one query. So massive improvement. And so where I'm seeing or where are we going, like with Wondergraph and what we're doing is, so I think the trend we're seeing is companies adopt AI and LLM, and they will increase the speed and velocity and productivity of their developers. If you do that, you need some sort of orchestration layer, an operating system. You need a place where the 1,000 developers can efficiently collaborate on what they are now building at lightning speed. So now
Yes.
everybody's running faster. Everybody can build and modernize faster. They have more output, more velocity. But all of this energy, where is it going if you don't have a means to organize it, to have people collaborate, work together? And the foundation of, let's say you have 1,000 devs and everybody builds services. What is the foundation of bringing it all together, making it reusable for everybody else? You need to encapsulate your business logic as a service, expose it as a strict contract. We now know why. We just discussed this problem. So you need a
Yes.
strict contract, and you need to be able to share it with the rest of the company or even like partners, external, internal, whatever. So you need a platform where you can get like a bird's eye view on where are we currently at with our APIs. Then you can search and leverage AI capabilities to immediately, to quickly understand what is the current API landscape doing. Can it solve my problem? So it's a question of exploration, of understanding APIs, of finding APIs that solve your problem. So that is one big part. So bird's eye view, exploration. And then if it is not able to solve your problem, then you want to be able to find like the right stakeholders, the right people, the right code owners. You want to collaborate with them on design. And once you have figured out a good design for your new functionality, once you have figured out like the right place where to put it, you want to immediately go back to your vibe coding, whatever cursor. Now you can code that, publish, bring it into your API architecture, make it accessible to everybody else, make it searchable, make it findable, reusable, etc. We don't want duplication in this world. Yeah, and then we essentially built like a I would say like an operating system, or a principled approach, so that you can really leverage the power of AI in terms of development. And we give you like the missing piece in terms of collaboration, so that it's not all just this, spinning the tires and creating lots of smoke, but actually bringing the horsepower on the road and enabling this collaboration. And I think this is going to be like a huge productivity boost if we can enable big orgs to not just build services fast, but actually build services fast that also fit together in the bigger picture.
I'm going to close with a comment that is one of my favorite. Is from Henry Ford, where they said, if I would have asked them what they would have wanted, they would have said faster horses. And if you ask companies what they want, they're saying, we want our developers to be faster. They want this and that. But what they actually want is the car, which is Cosmo, the collaboration and everything is we're modernizing everything. They don't actually know that's what they want. But what they see is, I just want to move faster and break less, and I want to modernize my stack. But they're just saying, I want faster horses. I think that example is spot on. I'm excited for what we're building. Guys, let us know below which format that you like better. If you like recorded videos, let us know. We prefer live because it's a little bit more fun for us. But the good thing is, oh wait, I actually messed that up. Jens, what is the good thing?
The good thing is we're back live next week, right?
Yeah, we're back live next week. Thanks, guys.
Okay.
I'll see you guys on another episode of The Good Thing. Thanks again, Jens. Great episode.
See ya.